Alright guys, January 4th through the 8th, Happy New Year. We've made it into 2021. Hopefully this year will be a little bit better than 2020. And hopefully we're getting back into person and, can try to get a little bit of normalcy. But if you are at home, please make sure you have lesson 19 in front of you. We are going to be looking at what we call the remainder theorem. This is something that not only are you going to see here, but you will see if you take pre-calculus, if you go on into any upper math, some college math, you are probably going to see what they call the remainder theorem. So our goal today is to know what the remainder theorem says and to be able to apply that remainder theorem. Alright, so let's go ahead and dive into exercises 1 through 3. So it says, consider the polynomial function f of x is equal to 3x squared plus 8x minus 4. So there's two parts. A, it says divide f by x minus 2. So what it's wanting us to do is they want to divide f of x by x minus 2. Well, f of x is 3x squared plus 8x minus 4. And we want to divide that by x minus 2. Alright, so what I'm going to do is I'm going to kind of work this out on a separate sheet of paper. You've got a back that you can go to, but I'm just going to do this right here on a separate sheet of paper. That way I don't have to keep flipping my paper over. But make sure that you do have this down. I'm going to use long division just because I like it a little bit better than the reverse tabular. Alright, so x goes into 3x squared, 3x times x is 3x squared. 3x times negative 2 is negative 6x. And I'm going to subtract all of that. So 8 minus a negative 6 becomes 8 plus 6, that's 14x. And I'm going to bring down the negative 4. So x goes into 14, x 14 times. So I have 14x. 14 times negative 2 is negative 28. I'm going to subtract. And you can already see that we're going to have a remainder. So negative 4 minus a negative 28, so that's negative 4 plus 28, would be a remainder of 4. So, a remainder of 24. So my answer would be 3x plus 14 plus 24 over x minus 2. Alright. The second part here says find f of 2. Guys, when we read this, we read it f of 2, which basically means all I'm doing is I'm plugging 2 in for whatever variable it tells me up here. So I'm plugging 2 in for x. So I would get 3 times 2 squared plus 8 times 2 minus 4. So 2 squared is 4, that'd be 12. Plus 8 times 2 is 16 minus 4. I get 28 minus 4 is 24. Okay? Alright, let's look at number 2. Consider the polynomial function g of x is equal to x cubed minus 3x squared plus 6x plus 8. I want to divide that by x plus 1. So it wants us to divide g of x by x plus 1. G of x is x cubed minus 3x squared plus 6x plus 8 divided by x plus 1. Alright, so let's come over here and let's work this out. X cubed minus 3x squared plus 6x plus 8. I want to divide that by x plus 1. Alright, so x goes into x cubed x squared times. So I get x cubed plus x squared. I'm going to subtract that. So I get negative 3x squared minus minus 1x squared. So that's negative 4x squared. Bring down my 6x. X goes into negative 4x squared, negative 4x times. So that's negative 4x squared minus 4x. I'm going to subtract all of that. So I get 6 minus a negative 4 is 6 plus 4. So that's 10x. I'm going to bring down my 8. Alright? X goes into 10x 10 times. I get 10x plus 10. I'm going to subtract all of that. So 8 minus 10 is negative 2. Alright, so my answer here would be x squared minus 4x plus 10 minus 2 over x plus 1. Remember, our remainder goes over top of whatever we are dividing by. So now it says find g of negative 1. So in other words, I want to put negative 1 in for x. So I get negative 1 cubed minus 3 times negative 1 squared plus 6 times negative 1 plus 8. Negative 1 cubed is negative 1. 1 squared is 1. 1 times 3 is 3, so I get minus 3. Plus 6 times negative 1 is negative 6. Plus 8. Alright, so I get negative 4, negative 10. So I have negative 10 plus 8, which is negative 2. Alright, let's look at number 3. Consider the polynomial function h of x is equal to x cubed plus 2x minus 3. So they want us to divide h of x by x minus 3. Alright, h of x is x cubed plus 2x minus 3. So we need to divide that by x minus 3. Be really careful when you're doing your division here, because you notice I am missing some terms. So we need to fill that in. So we have x cubed plus 0x squared plus 2x minus 3. Alright, so x goes into x cubed, x squared times. So I get x cubed minus 3x squared. I'm going to subtract all of that. 0 minus a negative 3 is 0 plus 3. So 3x squared plus 2x. X goes into 3x squared 3x times. So I get 3x squared minus 9x. Subtract all of that. 2 minus a negative 9 is 2 plus 9. That's 11x minus 3. X goes into 11x 11 times. So 11x minus 33. So negative 3 minus negative 33 is negative 3 plus 33. So I get 30. So my remainder is 30 here. So my answer is x squared plus 3x plus 11 plus 30 over x minus 3. Alright, now it says find h of 3. So I'm going to plug 3 back in for whatever letter h has attached, and that's the x. So I get 3 cubed plus 2 times 3 minus 3. So 3 cubed, 3 times 3 is 9 times 3 is 27, plus 6 minus 3. 27 plus 6 is 33, minus 3 gives me 30. Alright, so we're going to take just a second and we're going to kind of look at this for a minute. I want to discuss a couple of things. So I want you to go back and look at what was f of 2. F of 2 was 24. G of negative 1 was negative 2, and h of 3 was 30. So looking at that, do you see a pattern? Well, if you will notice, my number here is the same as my remainder. Alright, so 24 and 24, negative 2, negative 2, 30 and 30. So stating this in more general terms, here's what we can say. The remainder found after dividing p, whatever, the f of x, g of x, h of x, whatever, by x minus a will be the same value as p of a. So let's kind of take a moment and think about this in terms of something a little bit simpler. I want you to think about 13 divided by 4, or 13 fourths. When we have this, a lot of times we were told to create it, to rewrite it as a mixed number. Well, think about this for just a second. I can rewrite 13 as 4 times 3 plus 1. Alright? Well, think about this. If I were to write this as a mixed number, I would say 4 goes into 13 3 times. That gives me 1 left over. So it's in a connection to what we're doing here with the remainder theorem. So we can apply this to the same, to polynomials also. So if I look at going back to number 1, I had 3x squared plus 8x minus 4 divided by x minus 2 was equal to 3x plus 14 plus 24 over x minus 2. So if I were to multiply both sides, let's just say that I wanted to figure this out. If I multiply both sides by x minus 2, I want you to look at what I get. I get f of x, which was my original 3x squared plus 8x minus 4. I get f of x is equal to 3x plus 14 times x minus 2 plus 24. Okay? I would multiply everything by x minus 2. When I multiply this by x minus 2, it cancels out. When I multiply this by x minus 2, this is what I get. When I multiply this by x minus 2, the x minus 2's cancel out, and I'm left with 24. So this is basically what I'm doing is I'm introducing you to what they call the remainder theorem. Alright? So we can generalize this. We can generalize and say that p of x, and this could be f of x, g of x, h of x, whatever. We're just going to use p of x as general, is equal to q of x, that is our quotient, whatever we got when we divided, times x minus a, which is what we're dividing by, plus our r, which is our remainder. Okay? So this is what the remainder theorem states. Okay? The remainder theorem states, let p be a polynomial function in x, and let a be any real number. Then there exists a unique polynomial function q, such that the equation p of x is equal to q of x times x minus a plus p of a. Alright? So this is our remainder theorem. And that is true for all of x. That is, when a polynomial is divided by x minus a, the remainder is the value of the polynomial evaluated at a. Okay? So if you'll go back for just a second, I want to talk to you about where they get that a. Guys, I was dividing by -2. That is in the form of x minus a. So that's why I got, what is p of 2? This was x minus, or x plus 1, so I decided to find g of -1. This was x minus 3, they decided to find x of 3. Alright, so we're going to kind of use this here if you're still a little confused. But when we figured this out, I can figure out my remainder just by going, okay, I'm dividing by x minus 2, so I want to find f of 2. I'm going to find the opposite of whatever this number is right here. All right. So let's look at example number 4, or exercise number 4. It says, consider the polynomial p of x is equal to x cubed plus kx squared plus x plus 6. Find the value of k so that x plus 1 is a factor of p. Alright, so in order for x plus 1 to be a factor of p, the remainder must be 0. Alright, so let's figure out why. Why would the remainder have to be 0? I could plug negative 1 in for x, but the only problem is I don't know what k is to go from there. Alright, so I want to divide by x plus 1. We cannot actually go through and do a whole lot of the math because I don't have a number here for k. So this is one of those kind of brain teaser type problems that I have to think through. Alright, so with that being said, then since I don't know what k is, I want my remainder to be 0. So how could I figure out what my remainder is, or what my number is if the remainder is 0? Alright, so I'm going to go ahead and put, for x plus 1 to be a factor, the remainder must be 0. Okay? Now, since I want my remainder to be 0, what I can do is I can now look at figuring out that remainder. If you remember, I told you that I am going to basically substitute the opposite of positive 1 in for p. So we must have my p of x, or I want it to be p of negative 1 to equal 0. Alright? So, here's what I'm going to do. I'm going to plug in 0. I want it all to equal 0. And now I'm going to plug in my negative 1 for everything that I know. So, negative 1 cubed plus k times negative 1 squared plus negative 1 plus 6. Alright? And now I'm just going to basically solve this as an equation and figure out what k would be equal to. Okay, so I have 0 is equal to negative 1 cubed is negative 1 minus, or plus, I'm sorry, because negative 1 squared is 1 plus k minus 1 plus 6. Combine all your like terms, and I get 0 is equal to k, negative 1 plus negative 1 is negative 2, plus 6 would be plus 4. If I solve this, 0 is equal to k plus 4, I solve this as an equation, k must equal negative 4. Alright? So k is equal to negative 4. So I've done exactly what they've asked us to do. I found the value of k. So B says find the other two factors of p for the value of k found in part A. Alright? So, now that I know what my k is, I can do my division. Alright, so now that I know I'm looking at the problem, I want to divide by x plus 1. And I am dividing x cubed minus 4x squared plus x plus 6. And I just substituted in the -4 for k. Alright, so x goes into x cubed, x squared times. So I have x cubed plus x squared. Subtract all of that. -4 minus x squared would be -5x squared plus x. X goes into -5x squared, -5x times. So -5x squared minus 5x. Subtract. X minus a -5 would be 1x plus 5x. That's 6x plus 6. X goes into 6x 6 times. So 6x plus 6. Subtract that, and we said that we wanted our remainder to be 0, and that's what we got. So, I know, let me back this out just a little bit. I know that p of x is equal to, I divided by x plus 1 times x squared minus 5x plus 6. Excuse me. But it says find the other two factors. We already know that -1 is a factor. Now they want us to figure out the other two factors. Well, that's simply factoring out this polynomial over here. So let's factor this, x and x. Now remember, it's a minus plus, so I want to be able to add my factors of 6 to get 5. Alright, so we know that that has to be 3 and 2. And they're both going to be negative. And now I have my other two factors. So I would be able to factor this polynomial into x plus 1 times x minus 3 times x minus 2. Okay? Remember that for any polynomial function p and a real number a, that the remainder theorem says that there exists a polynomial p so that p of x is equal to qx times x minus a times p of a. So what does that mean if a is a 0 of a polynomial p? Alright? That means that p of a would equal 0. That means we would have a remainder of 0. Alright? So we also have what we call the factor theorem. Alright? I'm going to kind of introduce you to that. What is the factor theorem? The factor theorem says let p be a polynomial function in x and let a be any real number. So if a is a 0 of p, then x minus a is a factor of p. Alright, so let's look at what that means. Let's say that I wanted an example of a polynomial function with zeros of multiplicity 2 at 1 and 3. Alright? So I said I want my function with zeros of multiplicity 2. Remember, that means that's how many times it's going to occur. And I want that to be at 1 and 3. I want my zeros to be at 1 and 3. So if my 0 is at 1, then I know it has to be x minus 1. And I told you I want that to be a multiplicity of 2. Alright? I also want my 0 to be at 3. So that would be x minus 3 and the multiplicity of 2. Alright? So let's say, what if I want to give an example of a polynomial function with zeros of multiplicities 2 at 1 and 3. Is there another way I could do this? Could I give another example? I want to keep the same information. I still want my zeros to be at 1 and 3, and I want them to have a multiplicity of 2, but can I do it a different way? Well, I can. If I still keep my zeros at 1 and 3 with a multiplicity of 2, but let's say I decide to multiply the whole thing times 4. I still have zeros at 1 and 3, and I still have multiplicities of 2, so it does not change that information. If we know the zeros of a polynomial, does the factor theorem tell us the exact formula of the polynomial? No. But if we know the degree of the polynomial and the leading coefficient, we can often deduce the equation of the polynomial. In other words, we can figure that out. Alright, so let's look at example number 5. Consider the polynomial p of x is equal to x to the 4th plus 3x x cubed minus 28x squared minus 36x plus 144. So it says, is 1 a zero of the polynomial p? Well, I can look at the graph and I can see, okay, if 1 is a 0, then it should hit on the x-axis at that point. So if I go to 1, and we're counting by 5s, 4, 3, 2, 1. So if I go to 1, does my graph hit at that spot? It does not. So 1 is not a 0 of this polynomial. Is x plus 3 one of the factors of p? Well, let's think about this. Once again, guys, I don't have to do long division here. You're asking me, is x plus 3 a factor? Well, that means x would be equal to negative 3. So I'm going to come to negative 3. Is that a 0? It crosses the x-axis at negative 3, so yes, that would work. And I can actually prove this by saying, okay, I'm going to look at p of negative 3. So I'm going to put that in. Negative 3 to the 4th plus 3 times negative 3 cubed minus 28 times negative 3 squared minus 36 times negative 3 plus 144. Alright? Now, if I work all of this out, then I get negative 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So I get 81 minus 81 minus 252 plus 108 plus 144. That should all equal 0. If this is true, everything should equal 0. Well, let's figure that out. 81 minus 81 is 0. So I have negative 252 plus 108, which would give me negative 144. Negative 144 plus 144, look at that, we got a 0. So we were right, yes, x plus 3 is a factor. The graph of p is shown to the right. What are the zeros of p? Now, this is kind of difficult, so we've got to be really, really careful. We're going to say approximately, because when we have a graph drawn out for us, unless we can actually prove it on a graphing calculator, then we're going to say approximately. And I'm just going to start over here. So at approximately negative 6, negative 3, 2, and then again at 4. So these are the zeros that I can visually see on my graph. So it says write the equation of P in factored form. So since I know these, and I do not have to go and do long division here. I do not have to do long division to work this out. I already know my zeros, so guess what? I can go P of X would be equal to the opposite of -6, so X plus 6, times the opposite of -3 is +3, so X plus 3. The opposite of 2 is -2, so X minus 2, times the opposite of 4 is -4, times X minus 4. So this is what my polynomial would look like in factored form. Alright. So, not extremely difficult here. Alright, let's look at exercise 6. Consider the graph of the degree 5 polynomial shown to the right, with x-intercepts at -4, -2, 1, 3, and 5. Write a formula for a possible polynomial function that the graph represents using C as a constant factor. Okay, so, in other words, it's telling me that I'm probably not just going to be looking at an x to the 5th plus something x to the 4th plus something x to the 3rd. I'm probably having some sort of coefficient attached to my x to the 5th. Alright, so I'm going to go ahead and just start out by saying that C is going to be multiplied by everything. Alright, so now it says we have a 0 at -4, so x plus 4, times, I have a 0 at -2 is x plus 2, times, I have a 0 at 1, so x minus 1, times, I have a 0 at 3, so x minus 3, times, I have a 0 at 5, so x minus 5. Alright, so now we already know that this is probably not the only function that we can write, but this is one function that we can write. I have a possible polynomial function with all of my zeros, and C is a constant factor. In other words, it's being multiplied by the whole entire thing. Alright? So now it says, suppose the y-intercept is -4. Adjust your function to fit the y-intercept by finding the constant factor of C. Now, how would I do that? If I want my y-intercept to be -4, alright, so I'm trying to figure out the easiest way to explain this to you to not confuse you. And I don't know that there is a way to do that. So what I want to do is I'm going to give you the answer, and then I want to work on probably the simplest way. Like I want to see if I can find the simplest way to explain this to you. And it may be I'll have to create another video if we don't make it back to in-person, or if we're in-person, hopefully I can, explain that to you. But for right now, let me just kind of explain this to you. What's going to happen is this constant is going to have to change. All right? I need to figure out that constant because I want my y-intercept to be -4. Now, if you remember, our y-intercept is where the graph would intersect the y-axis. So I want my equation to show that it crosses the y-axis at -4. Alright? My zeros do not change. Okay? So therefore, I'm keeping the same function. My zeros do not change. So what this is going to look like, I'm going to change this constant, but my zeros will still be x plus 4 times x plus 2 times x minus 1 times x minus 3 times x minus 5. Alright? And I just need to put something in front of that. I need to figure out that constant c. So, the answer to this is 1/30. Alright? And like I said, I'm going to work on, and I probably should have already had this done, but, you know, I'm kind of trying to get everything done and looking at it. But let me sit for a moment and see if I can come up with a simpler way to explain this to you so that it's not extremely confusing. Alright, so for right now, just go ahead and write the answer down. I'm going to work on an explanation that doesn't use a whole bunch of technical terms so that you can figure this out. I don't think that anything that you have to do after this is going to require you to do this. So it'll be okay. Alright guys, have a great week. I will work on that explanation and I'm hoping to see you guys soon. Have a great week.